Welcome. I think we have good numbers, so we can start. More importantly, I need to stop about 5 minutes early today. I have a meeting in the department which is between 10 and 10:10. So it might be odd if I go late to that meeting. So we'll stop at 9:45 and then I'll leave. Okay. Any comments, questions? I think this is where we finished up last time. We are looking at examples of initiation reaction of free radicals, reactive species, and this one was out of a discussion on the photolysis using light to equally split a bond, a covalent bond, so that each of the parts takes an electron and becomes a free radical. Okay. And then that is also responsible for all the difficulties to your skin that, or a lot of difficulties to your skin that sun causes, and so on and so forth. So these two videos were supposed to throw some light on that. Hopefully you got to see those videos. They are available to you all the time. So please watch them whenever you want. That's okay. Okay. Move forward. Good. Okay. Some more information. In the troposphere, atmosphere, part of the atmosphere, photolysis of nitrous oxide yields hydroxyl and nitric oxide reactive species. Okay. You may have looked at this if you had looked at atmospheric chemistry or some related aspects in your 11th standard, 12th standard. Okay. So this is certainly relevant there. And this is the reaction of relevance photolysis using UV light of nitrous acid to give you a hydroxyl radical and a nitric oxide radical. They rapidly oxidize other organic compounds in the atmosphere and thus contribute to atmospheric pollution, which is a big thing. It has become a really bad thing. It's so bad that you cannot walk out especially if you go from places that you're not used to Delhi. You cannot walk out in the morning and not have a sore throat. It's that bad, really bad. I didn't quite believe it till I went there. We need to go there for various meetings and so on and so forth, some national level meetings. So get up early in the morning, walk around, really bad, especially in November and things like that. November, December is horrible. And of course, the visibility is so low and so on and so forth. Various reasons. Let us see when that gets done. Okay. Any comments, questions? Okay. Now let us look at radiolysis using radiation to split things. Or the use of high energy radiation, especially to split water, is called radiolysis. This is what happens if you irradiate water with gamma rays, appropriate energy, then it splits into hydrogen radicals and hydroxyl radicals, H dot and OH dot. Again, this is due to equal breakage of the bond. This is due to radiation, and therefore you call it radiolysis. Earlier one was due to light, and therefore you call it photolysis. And we'll come back to this a little later, the third chapter, when we look at measurement of kinetics and so on and so forth. It's a little relevant there, so I'll give some more details when we discuss it in context. Okay. One more. A lot of split reactions or initiation reactions by splitting the bond. Please watch this video. I'll also run through this video. It's nice to understand why things happen and so on and so forth. This is a video on boiling and as a function of pressure. We've all done this as a part of thermodynamics, but when you do that as theory, it's something, and you see the relevance, then you understand it a lot better and so on. This kind of understanding is needed for us to appreciate whatever we're going to discuss next. So please take a look at this video. On your Moodle page, all of you have access to Moodle, right? Anybody not having access to Moodle? What happened was one of the videos was not available. So I put in a new video, but I didn't animate it. So we started looking at ultrasound, right? And then it has a lot of applications. This video, the first video, gives you the applications in imaging for medical purposes, right? And the basic principle is that you use high frequency vibrations and use appropriate contrast agents and get an image based on the reflections of those vibrations, of those sound waves back to your receptor. So, while doing this, the high frequency vibrations cause formation, growth and collapse of air bubbles, of gas bubbles in the liquid, right? And then this video gives you a link between pressure and bubble formation. As we are all used to 1 atmosphere pressure most of the time, therefore we mentally fix 100 degrees C for boiling of water, but it can happen at much lower temperatures if the pressure is lower. We all know this from school, we have formalized this in thermodynamics, but this is the practical consequence of that. Okay, good. And do you know what the term means? Cavitation? Some of you do.
The bubbles will go and destroy things normally in mechanical systems.
In all systems. In biological systems, easier to destroy. So, when there are bubbles that form in any situation, if the bubbles break, they release a lot of energy. Sonication, yes, that's the principle by which sonication works. You use ultrasound, and that causes bubbles which break, which release energy, and that can break open the cells easily, and so on and so forth. Breaking open the cells itself is quite a bit of energy, but we are looking at energies that can cause cavities on metals. Okay, that high pressures and temperatures are possible when the bubbles break. Okay, and the formation of cavities is called cavitation. Okay, let's understand that a little further. You might want to look at that video. I checked the availability of these videos a couple of weeks ago. I hope all of them are available. I did replace the videos that were not available and so on. So I'll also check anyway. So it has so happened that the previous day I've checked and the next day it has become unavailable and so on. So I've been changing these videos and finding these videos which exactly fit in with the narrative here is not easy. It takes quite a bit of time. It has to be between 2 and 3 minutes, otherwise just too long and so on and so forth. So quite a bit of work there. Go ahead, please. So that explains cavitation. The earlier video that went missing a few months ago was on impellers in submarines. Okay, and if they rotate it at a certain speed, then there's a lot of cavitation on the propellers, and it leads to failure of propellers and so on and so forth. So it can have wide-ranging effects. In this case, it was pumps, bad enough. Metal, that gives you an idea how much energy is being released. But it can also be high profile, such as impellers for submarines and so on and so forth. Okay. So under such conditions, homolytic fission of water takes place to yield hydrogen and hydroxyl free radicals, similar to radiolysis, but the mechanism happens to be different. Chemical mechanism happens to be different. We are not getting into all those. We don't get to those levels of details in this course. Our focus is on reactive species. In a biological system, use of ultrasound can very well lead to cytotoxicity because of this. Okay, what is causing the image are these ultrasound waves, right? When you're going to cause ultrasound, of course they'll take care to have it in a certain range and so on and so forth. It won't be as high as what is needed to break open cells in a homogenizer, right? But still, be careful. That's the reason why I'm always I'm a little conservative. I grew up amid medical doctors. I take things out of for need. Certainly, I'm not against any branch of medicine, but I'm a little wary of too many scans. Okay, so you go for a health checkup. They do your abdominal scan, ultrasound, and so on and so forth. I'm a little wary, but once in a while it seems okay because I know that this can happen. Okay. So be a little careful. I'm sure the doctors would have done some of these, but the doctors happen to be again practitioners. They do one course in biochemistry, okay, in their entire curriculum. Their curriculum was up for review for a very long time. I mean, I've been I've been vocal about it for the past 20 years or so. But it's more of practice. MD PhDs are, they have a strong grounding in research and so on and so forth. That's coming up in a big way in our country also. So they have an understanding. They can always relate to fundamental aspects, and you need these. You need these to ensure that these things are happening. So you go and talk to a practicing doctor that there are papers that creatinine is not indicative of kidney malfunction, not a proper indicator of kidney malfunction. There are papers in 2020, 2019. They think you know nothing. Okay. Show them a published paper and published in a good journal, not a fly-by-night journal. That number, 6, no, you'll have to go do dialysis, kind of a thing. So, my own relatives. So, so that's their training. So they need some grounding with what it means also. And all these have been developed for a certain purpose. I mean, all scientists need to know this. Things are developed for a certain purpose. If you don't use them for their purpose, either knowingly or unknowingly, then you're going to draw incorrect results, right? Did I tell you the story about the paper we wrote on Blind-Dyer method? No. Oh, then I should tell you this at this time. Blind-Dyer method was published in 1945 for lipid analysis. Okay. It was developed on mammalian cells. Subsequently, it has been used. It's a nice assay. It works well in many hands. Not too difficult. Once you get it, you get it. And from that time onwards, it has been heavily used for lipid estimates from various different systems. Okay. In the mid 2000s, there's a lot of interest in lipids from microalgae, bio-oil, right? Bio-oil is nothing but lipids from microalgae. These are accumulated lipids. So we also started go into the literature. You look at it, the Blind-Dyer method, nice method. We started estimating lipids. Okay. In 2009 or 2010, I think, one of our project students, Archana, and these two were from Shastra, Archana and Sandhya. Yeah. They came and told me, sir, there is some green color that is coming out when we do this assay. Why should the green color come? I investigate that. That's interesting. Why should a green color come? Lipids are off-white and so on and so forth. So then they figured out that this method extracts chlorophyll, okay, which is not a lipid, which is not the lipid that we want. And chlorophyll, it can tilt your results by as much as 25%. Huge, right? And so they went through it. Then they realized you cannot use Blind-Dyer. I mean, they did the analysis. They ran all these assays, high-profile assays, and pinned it down to chlorophyll. They showed that chlorophyll is coming out of this. You cannot use this assay for photosynthetic systems. It was developed fine. It was developed for mammalian cells. It is perfectly fine. People didn't realize that these things can happen, and therefore they started using it for various things. That's part of the way science progresses. And then we realized this. So then they found another method which will not extract chlorophyll and so on, which will not let chlorophyll contaminate the data. And then we redid all our analysis to get the appropriate lipid amounts, bio-oil amounts, and so on. And then we wrote up a paper. We sent it to Biomass and Bioenergy. It's one of these big things and well-known things. No response. Okay, this is another story, but I might as well add it here. No response. After this is 2010, I think. After 6 months, I sent a reminder, no response. After 8 months, after the 5th reminder was, I'm withdrawing the paper, and because I need to send it to some other journal. So 3 weeks after that, I get a note. When I was busy with administrative work at that time, I was the head at IIT Hyderabad, setting up that department. I was the head of SAFE here, so heavy work. So I used to go to SAFE in the morning, early in the morning, lock myself up and said, don't disturb me till lunchtime. All administrative work comes after lunch, and then work on these things. So then 3 weeks after the thing, I get a note from the editor. This is, by that time, a year and 3 months had passed. I get a note from the editor saying, sorry, the previous editor passed away. And I looked at this, are you still interested? I said, yeah, when so much time, I'll have to send it fresh to another journal anyway. I said, yeah, please consider. And then the person said, just change the title. We did not include the name Bly-and-Dyer method in the title. So included Bly-and-Dyer method in the title, publish. It was published after with no this thing, because the person knew the value of it. And it is a well accepted paper, people quote it and so on and so forth, because it shows that Bly-and-Dyer method cannot be used for lipid extractions from photosynthetic systems. It works well in mammalian systems. In non-chlorophyll containing systems, it works well, and so on. So be a little careful. So this needs to be kept in mind whenever assays are developed or whenever assays are used. Always, that's the reason why we insist on people knowing the principles of assays. Then at least you have a fighting chance of making your own decisions. You might still make errors, but you have fighting. You have the background to figure out what is right and what is not. Okay. So it can be a little careful. One of the examples is, again, I have a lot of these personal anecdotes. These I had formulated a while ago. I went through my cataract surgeries only a couple of years ago. There's a lot of commonality. Something called phacoemulsification, photolithotrypsy, and so on and so forth. Except for the medical doctor here, have you all heard about these names? I'm sure he has heard. No. Okay, we'll talk about this. None, right? Okay. Phacoemulsification is used during the removal of cataract. You all know what cataract is, right? The lens, it has a crystalline, which is a crystalline protein, which helps you see. That's the lens material. Over time, that degrades, and therefore it forms an opaque layer, and you cannot see properly. So the only way is earlier to remove the lens and then give you an external lens. And nowadays things have come quite a bit. They use intraocular lens, where they put in the lens into your eyes so that you don't have to wear something, and so on and so forth. And for some people, just one correction is good enough, depending on their eye structure and the corrections that were needed at the time of surgery. For some people, you need both near vision and far vision, like myself. And then you have much more expensive intraocular lenses that have various refractive indices on different diameters, and therefore one lens is good enough for you to see. You need to get used to a different feel while you see for a while. And then of course, there are these nice rainbow halos around lights that can be bothersome initially. That's the reason why they ask you not to drive at night. That's a nice, then your brain kind of gets used to it. You get this nice rainbow halos around lights and so on and so forth. Okay. So while removing the cataract, the standard practice nowadays in all our hospitals even is to use ultrasound to shatter the eye lens and then suck it out. Okay. The eye lens is actually inside a pouch, a transparent pouch. So they make a small cut in the pouch. That small cut can be made using a laser or a knife. In my case, it was a knife. Therefore, they had to suture it for a week. In many cases, it's a laser, so a very tiny laser cut, ultrasound, shatter the lens, it becomes gooey, they suck it out, and then it gets sealed in some way. They don't use a suture when they use this laser thing. So this laser thing is very different from the LASIK surgery. LASIK surgery is changing the curvature of the a part of the eye. Okay, that helps you with the correction a little better. Okay, so while this ultrasonication is used to shatter the lens. Okay, you need very high energies, right? You put in that much of energy into your eye, and you have rather sensitive cells around them. You need to be careful. Okay, I was a little alarmed, and I mean, because I knew all this, I was teaching these in courses much before I went through the surgery. So, one of these, the doctor is known to me, but you cannot ask the doctor. So, I asked the assistant, do you use laser? He said, yeah. I mean, do you use ultrasound? He said, yeah. Vacuum emulsification? He said, yeah. Do you use anything in the eye to take care of the eye? Then he was not too sure, because they use a lot of things. Then I said, do you use hyaluronic acid? Yeah, some mixture with hyaluronic acid we use in the eye when we do this procedure. Fine. Good. I was relieved, because doctors are sensitive. You need to be a little careful. You ask them too many questions, they get very angry. So, including my own relatives. So, don't show off your half knowledge. Even if you have better, I mean, seemingly better solutions. When you talk to a doctor, you listen to whatever he says, he or she says, then come out and do it. No, I'm joking. If, the official position is that follow doctor's orders. Coming back to this, okay. So the broken up lens is removed by aspiration, which is essentially sucking it out. This is another video you might want to see. If you're a little queasy, you might not want to see, but try it out. If you're queasy, just stop.
Sir, are they not render you unconscious with surgery?
Oh, I was fully aware. Cataract surgeries are not done under general anesthesia. Local anesthesia, yes.
Did it hurt?
No, local anesthesia. They completely block this part of the eye. You don't feel it.
It looks like quite an experience.
Yeah. So you're queasy. You're queasy. So you shouldn't get into surgery. Yeah, this is the bread and butter of surgeons. So they know how to handle it. Some of them, it's a learning experience. They want to be surgeons, but they have difficulty. They cannot stand the sight of blood and so on and so forth. So some of them, our doctor might have better experiences to narrate. So he's caught up in that.
Did they put hooks in your eyes in the video?
Yeah, they keep the eye completely open, and then they wait till you're unable to move the eye. The exercise is see here, see here. So they keep, in my case, they kept doing it till I suppose I couldn't do it anymore. So then they know that the eye is not under my voluntary control. Eyeball is not under my voluntary control, therefore it is anesthetized. So those are well developed, those anesthesias are well developed, very effective. I didn't feel a thing. And then the course of, what do you call it, pain killing medicines was perfect. I didn't feel a thing anything throughout, and I was fine. Maybe a few weeks later, I would feel some pressure at some point in time, very minor. Yep.
But
yeah.
What does phacoemulsification actually mean?
What it actually means is the breakage of the lens with ultrasound, emulsifying it and then taking it out. The entire thing is called phacoemulsification. Why is it phaco? I don't know. In fact, I misread the term earlier and then I corrected it to phaco. I misread it as something for a couple of years, and then I saw it as phacoemulsification. It's not something else. That's a term that is used. Why phaco? I don't know. Emulsification is quite straightforward. Try to find out there. I'm sure there's a reason for it. If you find out, please let us know. So the hydroxyl radicals formed by homolysis of water can cause cell damage. You need to be careful. Why did I say, do you use hyaluronic acid? Any idea? Why did I ask him, do you use hyaluronic acid? Antioxidant. Yeah. Vitreous part also has hyaluronic acid. Very true. The eye vitreous, the inside part of the eye, that naturally has hyaluronic acid and so on and so forth. So do your joints and things like that. They're natural antioxidants, very powerful antioxidants. And therefore, hopefully, when they do it under a cover of this excess hyaluronic acid, the free radicals generated are negated. That's the way they minimize damage. Solutions containing hyaluronic acid, good antioxidant against hydroxyl, is used during the process. Any questions or comments?
Phaco's means lens. Phaco's means lens.
Phaco's means lenses. There. Please illuminate us with all these things. You confirmed also, yeah. So Phaco's means lens. So lens emulsification. Abbas asked this question. Good. Thank you. Any other comments or questions? Good. Okay. Another term, shock wave lithotripsy. Any guesses, given that phacoemulsification is that? What else is ultrasound used for to treat? Very well known this is. Kidney stones. Yeah, fracture, how?
Like, I've heard of, research that, ultrasound was used.
Maybe to improve the growth or something like that. Pardon?
Ultrasound was used to detect fractures.
Detection, yes, because that's imaging. It's used for very sensitive things also. Nowadays, when somebody is pregnant, they do a series of ultrasounds. I'm scared. But anyway, I'm sure the doctors know better. Every month there is something that is scheduled. Okay, because we haven't, our experiences are old, 30 years old, things change, hopefully for the better. What we'll do is we'll take up the shockwave lithotripsy, because I need to leave in a couple of minutes to make that meeting in a meaningful fashion. So we'll stop the class today. We'll meet again on Monday at 12, and we'll start with shockwave lithotripsy. Any questions or comments? We still have 1 minute. Okay, we'll meet on Monday.